Topic under discussion is eigenvalues and eigenvectors. And I found these links, I googled them rather, and I found these links to be simpler, and the examples are simpler, and the concept also is made simpler. So if I want to understand eigenvalues and eigenvectors, I need to brush up my matrix multiplication concepts and determinant concepts. So for matrix multiplication, I am using this link of Byju's. Again, for determinant of matrix, I am using this Byju's link. And for eigenvectors and values, I am using LibreText link. Linear algebra, first course in linear algebra by Cutler. So I have already clicked on them. So let me just check. So we'll directly dig into the example for matrix multiplication. This is my 2 by 2 matrix. So this is matrix A and this is matrix B. How do I multiply it? So I'll be taking the first element here, and 3 into 6 plus 7 into 5 will be 53. That will be the value of AB11. That is 53. Then 3 into 2 plus 7 into 8 will be leading to 62. That will become AB12. Then 4 into 6 plus 9 into 5, that will be 69, which is AB21. Then 4 into 2 plus 9 into 8, that will become 80, which is AB22. So this is my AB, which is the multiplication of matrix A and matrix B, which are 2 by 2 matrix and square matrix. If it is a 3 by 3 matrix, so again what I'll be doing is I'll be taking the first element here, 12 into 5 plus 8 into 6 plus 4 into 7, 136. That becomes AB11. Then 12 into 19 plus 8 into 15 plus 4 into 8, that becomes 380, which is AB12. Then 12 into 3 plus 8 into 9 plus 4 into 16, that becomes 172, which is AB13. So rest of the values will also be calculated. So this is my AB matrix, which is a multiplication of matrix A and matrix B, which are a 3 by 3 matrix and a square matrix. So this is a simpler example of matrix multiplication from Byju's link. And I'll be looking at how to calculate or find out determinant of a matrix by looking at this example. So this is my 2 by 2 matrix. So determinant of this matrix A is calculated as 3 into 3 minus of 4 into minus 1, minus 1 into 4. So that is determinant of A will be equal to 13. I have taken the diagonal elements. So similarly, if it is a 3 by 3 matrix, so let us directly look at the example. This is my 3 by 3 matrix. Now I want to find the determinant of this matrix A. So what I'll be taking my first element and I'll be excluding this row and column where this element belongs. So what remains is 0, 3, 5, 2. So this is my 4 value and 0, 3 and 5, 2. Then I'll be taking minus 3 and excluding this column and this row. I have 1, 3, minus 1, 2. That is 1, 3, minus 1, 2. I'll be taking the value 5 and I'll be excluding this row and this column. So what remains is 1, 0, minus 1, 5. So I can calculate the determinant of this 2 by 2 already. I know it. 0 into 2 plus 5 into 3, that is minus 15 into 4 plus 1 into 2 minus of minus 3. So that is plus 3. So 2 plus 3. Then 1 into 5 minus 0. So that becomes 5 plus 5. So that determinant of this matrix is 20. So using these two links, I calculated how to multiply the matrix and how to find the determinant of the matrix. Let us dig into eigenvalues and eigenvectors. Okay, so this is my matrix A, which is a 3 by 3 matrix. I need to compute the product AX. The value of X is this minus 4 minus 5 minus 4 minus, sorry, 3, and one more value is given 1 0 0. So for the first solution, where X value is minus 4 minus 5 minus 4 3, so I'll be taking the product of A and X, and when I take the product of A and X, I know how to do the multiplication, right? So 0 into minus 5 plus 5 into minus 4 plus minus 2 into 3, so that becomes minus 50, like that. So I'm getting minus 50, minus 40 and 30, and if I take 10 as common, so that becomes minus 4 minus 5 minus 4 3. So in this case, this AX resulted in a vector which is equal to 10 times the vector X, is it not? So it means AX is equal to 10x. AX is equal to 10x. So similarly, let us take the value of X as 1 0 0, and when I do that, I found out that the vector is equal to 0 times the vector X. So AX is equal to 0x. Now here, when we have AX is equal to KX, where K is some scalar value like 10, this scalar value is called as the eigenvalue, and this is represented by a symbol like this, which is lambda instead of K. So my lambda 1 value is 10 and my lambda 2 value is 0. So when the X value is non-zero, then it is called as an eigenvector. So here AX can be represented as lambda X, and here lambda is called as the eigenvalue, and X is called as the eigenvector. So now if AX is equal to lambda X, that can be represented as AX minus lambda X, or it can be represented as A minus lambda AX, or it can be represented as lambda I minus AX, which is equal to 0. Okay. Now for lambda I minus A, let us say it is invertible, so there is inverse exists. So let us put this equation X is equal to Ix, and I can be represented as lambda I minus A inverse lambda I minus A into X. So here lambda I minus A of X will be equal to 0. 0 multiplied by anything is 0. So it means what? X is equal to 0, but we want X to be non-zero. Therefore lambda I minus A cannot have an inverse. So if it is not inverse, then its determinant value will be equal to 0. So determinant, that's why determinant of lambda I minus A equal to 0. So lambda I minus A is a polynomial in the variable X, and it is called as a characteristic polynomial of A, and determinant of lambda I minus A equal to 0 is called as the characteristics equation. Okay. Now let us directly take an example to find eigenvectors and eigenvalues. Okay. Now what is the procedure for finding eigenvalues and eigenvectors? Let the matrix be a square matrix. First find out the eigenvalues lambda of A by using the equation determinant of lambda I minus A equal to 0. For each lambda, find the basic eigenvector X is not equal to 0 by finding the basic solutions to lambda I minus A X equal to 0. So let us take this example. This is a 2 by 2 matrix, okay, and matrix name is A. Now we need to find the eigenvalues. For that we have to solve this equation determinant of lambda I minus A equal to 0. So determinant of lambda I is a identity matrix 1, 0, 0, 1, as A is a 2 by 2 matrix. Now minus of a is minus 5 2 minus 7 4 equal to 0. So this becomes determinant of lambda plus 5 minus 2 7 lambda minus 4. So when I calculate this, the resultant will be equal to lambda square plus lambda minus 6. When I solve this equation, lambda 1 will be equal to 2 and lambda 2 will be equal to minus 3. So we need to find the basic eigenvectors for each lambda. So first we'll take lambda 1 equal to 2, and we want to find all vectors where x is not equal to 0 such that ax equal to 2x, is it not? So ax is equal to kx, ax is equal to lambda x, ax is equal to 2x, because lambda value is 3, because lambda 1 2 we are taking, right? So lambda I minus ax equal to 0, that is what we know, right? So lambda will be replaced with 2, so 2I minus ax equal to 0. So I is an identity matrix again, so here we are taking this x as xy will be equal to 0 0. Now once I simplify this, I'll be getting the values like this: 2 by 7 and 1. So 2 by 7. So for lambda 1 equal to 2, we'll be getting the eigenvectors as 2 and 7. Same thing you can apply for the other value, lambda 2 equal to minus 3, and derive the results. So this is a simpler explanation of eigenvalues and eigen